Scroll through any tech feed today, and you'll see a blur of tools promising one illusion: complex digital labor instantly executed with a single click. The core marketing claim driving this industry is that hidden or secret AI websites can autonomously generate a 10-page pitch deck, professionally master studio media, or run an entire marketing department while you sleep. There is no underlying magic here. There is no secret, singular artificial intelligence model executing these specific feats of productivity. This diagram strips away that glossy user interface to reveal what is actually happening. You are not looking at a specialized model. You are looking at well-engineered abstraction layers built on top of raw application programming interfaces. To understand the utility of these tools, we have to look past the marketing and reverse engineer the automation logic operating beneath the user interface. We can dismantle this entire industry by analyzing three specific technical paradigms: prompt chaining, domain-specific routing, and agentic event loops. The true value of these consumer wrappers does not lie in their outputs. It lies in studying their back-end architecture to see exactly how systems engineering translates simple human intent into complex, multimodal execution. We will start with web applications that claim to build fully formatted slide decks from a single sentence. The core engineering problem here is formatting. A raw large language model generates unstructured text. It cannot natively output styled web components, place images, or construct a multi-page user interface. This diagram tracks a technique called prompt chaining. When you type your single sentence into the UI, it is not sent directly to the language model. It is first intercepted by a middleware orchestrator. This orchestrator takes your short prompt and injects it into a massive, pre-configured expansion template, a hidden set of instructions that dictates the exact length, tone, and parameters of the desired response. This expanded prompt utilizes a constraint mechanism known as structured outputs. It forces the language model to abandon conversational text entirely, demanding that the response be returned strictly formatted as a JSON data object. Inside this payload, the unstructured text is now organized into required data keys. The system explicitly defines sections for slide title, bullet points, and image prompt. The back-end software receives this structured data and parses it. Because the keys are predictable, the system can map the text deterministically to specific React front-end components, placing the title text in the title header and the bullet points in the body container. Concurrently, the orchestrator pulls the generated image prompt key and executes a parallel API call to a completely separate image generation model, downloading the visual elements and placing them into the slide layout. The AI presentation maker is an illusion. It is a deterministic formatting wrapper strictly containing a text engine. Processing continuous multimedia signals requires taking a massive, chaotic wave pattern and instantly stabilizing it into strict order. This brings us to the tools that instantly scrub background noise from audio files or seamlessly replace the messy backgrounds of video clips. Generalized text transformers fail completely at this task. They are built to predict discrete tokens, making them computationally inefficient at processing massive, continuous signal arrays like millions of high-resolution pixels or audio samples. This diagram outlines domain-specific routing. Here, the automation layer does not generate anything. It acts purely as a traffic director. When an audio file enters the system, the routing logic bypasses the language models entirely. The data is sent straight to a specialized, compute-optimized neural network designed strictly for audio isolation. This specialized model relies on spectrogram-based separation, visualizing the audio as an image to isolate human voice frequencies while mathematically discarding the background noise. Video data is routed down a different path. It is pushed into a latent diffusion model, an architecture optimized specifically to handle continuous pixel arrays and temporal consistency. The system executes a process called masked inpainting. It automatically generates an alpha mask to separate the foreground subject from the background, and then diffuses the new environment into the masked area, handling the entire layering process invisibly. These tools function because of intelligent routing logic. They succeed by directing unstructured, continuous data away from generalists and into the exact narrow model designed to process it. The most complex claim in consumer AI marketing is the autonomous workflow. tools promising to read your emails, to quickly draft responses, and manage your social media calendar without any human intervention. These workflows require the system to operate as an active loop rather than a single, isolated generation event. This topology illustrates an event-driven architecture. The entire system sits completely idle, consuming zero compute, until a specific external trigger occurs. A webhook acts as the listener. When an external event happens, like an email hitting your inbox, the webhook captures the raw text payload and passes it directly into the central language model for analysis. This activates a core mechanic known as function calling, or tool use. The developer has provided the language model with a hidden, predefined list of external APIs it has permission to interact with. This capability changes how the model processes information. Instead of generating a conversational reply, it evaluates the input against its tool list to identify the most efficient programmatic action. Once a tool is selected, the model must output the precise JSON parameters required by that specific API. If it decides to schedule a post, it formats the exact date, time, and draft text fields. The orchestration layer takes those parameters and executes the final post request, sending the data out to the external service to complete the action. Autonomous agents are simply language models granted the structural permission and precise formatting constraints required to trigger external code and change the state of outside systems. Raw data moving rapidly across systems requires strict pathways to be useful. The power of consumer AI wrappers is built entirely on abstraction layer design. This diagram shows all three of these architectures merging into one unified cascading pipeline. A truly advanced application utilizes all of them simultaneously. Prompt chaining provides the structural boundaries, forcing raw text generation into usable formats. Domain-specific routing manages computational complexity, keeping continuous multimedia data away from inefficient text processors. Function calling enables real-world action, allowing the system to reach out and automate external software. The primary job of an AI developer is to build constraints. They engineer rigid architectures that force unpredictable stochastic models to behave as reliable, deterministic utilities. True leverage in the modern technical landscape does not come from knowing which consumer URL to visit. It comes from understanding the back-end architecture well enough to build these pipelines yourself.